In the heart of the Chilean Andes, on a wind-swept, arid mountain, an extraordinary machine is preparing to change forever the way we observe the universe. It is not just a telescope, nor a simple scientific instrument, but a kind of time machine, capable of capturing every subtle change on the grand cosmic stage. Here, where the air is crystal clear and the night appears darker than anywhere else, the Vera C. Rubin Observatory is about to inaugurate the largest optical exploration campaign ever conceived, the Legacy Survey of Space and Time, abbreviated as LSST. An undertaking that promises to produce a real movie of the universe, frame by frame, night after night, for 10 consecutive years. Imagine being able to witness, in real time, the movement of millions of celestial bodies. Asteroids racing like luminous dots between Mars and Jupiter, comets tracing ephemeral arcs across the sky, stars exploding as supernovae, and galaxies transforming before our eyes. For the first time, science will not be limited to capturing static images, but will be able to study the universe as a dynamic phenomenon in perpetual evolution. The Rubin Observatory, with its colossal 3,200 megapixel digital camera, the largest ever built, will be able to scan the entire southern sky every 3 or 4 nights, recording details unimaginable only a few years ago. Every shot produced by this gigantic machine holds the potential to revolutionize our knowledge of the solar system and deep space. The SORCA software, developed specifically to analyze LSST data, promises to identify millions of new asteroids, comets, trans-Neptunian objects, and even possible interstellar visitors. Astronomers estimate that, in the asteroid belt alone, at least 5 million new rocky bodies will be identified, an unprecedented trove of information about the primordial history of our planetary system. However, the narrative of this scientific endeavor is not just made up of numbers and technological records. Behind every pixel lies an intellectual challenge, distinguishing, among the myriad points of light, what moves from what remains still. Recognizing the trail of a potentially dangerous asteroid that, by just a few million kilometers, will skim past Earth's orbit. Or perhaps discovering, entirely by chance, a new object coming from other star systems, a rock like Oumuamua, crossing the solar system on an unpredictable trajectory. This is not science fiction, but the new routine of 21st century astrophysics. With LSST, planetary defense enters an entirely new phase, the ability to detect and track, almost in real time, asteroids that could one day threaten Earth. For each object identified, the collected data is immediately shared with a global network of observatories, sparking a genuine race against time to confirm orbits, calculate trajectories, and estimate risks. It is a team effort involving thousands of scientists, programmers, and enthusiasts around the world, each ready to contribute to the safety of our planet. And yet, the mission of the Rubin Observatory goes far beyond simple, space surveillance. As its giant lens scans the sky for moving objects, it also gathers a dizzying amount of data on variable stars, supernova explosions, and mysterious transient phenomena animating the celestial vault. In this way, LSST also becomes a powerful laboratory for cosmology. Every variation of light, every sudden change, every new appearance or disappearance in the cosmic background can conceal precious clues about the processes that govern the life and death of stars, the formation of galaxies, and even the very nature of dark energy. Behind the scenes of this colossal scientific enterprise lies a bold vision: to build the most detailed three-dimensional map of the universe ever created. Each night, as the telescope peers into the depths of the cosmos, Earth silently spins beneath its attentive gaze. The data collected is analyzed by powerful artificial intelligence algorithms, capable of distinguishing between genuine signals and false positives, of identifying new sources of light, and of following the path of millions of moving celestial objects. Thus, the observatory transforms into a true cosmic sentinel. No detail escapes its vigilant eye. In this race for exploration, there is also room for surprise and wonder. Not only professional astronomers benefit from this uninterrupted stream of data, Enthusiasts, too, thanks to open-source platforms and accessible archives, will be able to directly participate in the discovery of new celestial bodies, monitoring images in real time and contributing with their own analyses. The sky, which for millennia has been a mysterious realm reserved for a privileged few, now opens up to collective participation, becoming a vast, shared laboratory. Yet, as the surface of the solar system fills with new names and acronyms, LSST's gaze extends far beyond the familiar boundaries of planets and asteroids. The real beating heart of the survey is its ability to observe distant galaxies, to capture the faint light that has traveled billions of years before reaching our sensors. Each galaxy identified adds a piece to our understanding of cosmic structure, of the forces that shape the universe on a grand scale, and of unresolved mysteries such as dark matter and dark energy. There is a detail often overlooked when talking about astronomical revolution. Every galaxy that the Rubin Observatory records in its images is not just a cluster of stars, gas, and dust, but also a window into the deep past of the cosmos. The light reaching our instruments from these distant worlds set out when Earth was still young, long before life began to take its first steps on the floors of primordial oceans. Thanks to its sensitivity and extended observation capability, LSST will make it possible not only to catalog billions of galaxies but also to study their changes over time, mergers, collisions, stellar explosions, and the traces left by dark matter and dark energy. This three-dimensional mapping enterprise intertwines with one of the greatest challenges of modern physics: understanding the nature of dark energy, that mysterious force that seems to accelerate the expansion of the universe. Every supernova captured, every transient event analyzed, contributes to a huge cosmic puzzle in which distances, brightness, and galactic distributions can reveal the presence of this invisible energy. LSST is specifically designed to hunt for these signals, providing scientists with data on a scale never seen before and paving the way for new theories about the very structure of the cosmos. But it is not only about distant enigmas. The Rubin Observatory will work in parallel with other missions like SphereX, NASA's probe dedicated to observations in the near-infrared, to map the chemical composition of interstellar dust and search for traces of water in the most remote corners of the Milky Way. Every discovery, however small, can overturn established theories and suggest new scenarios about the origin of life, the distribution of habitable planets, and the evolution of galaxies. Even the very concept of a solar system is expanding, because seemingly anonymous objects discovered at the extreme edges of our star's domain can turn out to be keepers of ancient secrets or even messengers from other worlds. In this incessant flow of data, the boundary between professional science and public participation tends to blur. The Rubin Observatory represents one of the first major scientific projects to be completely open to the world. Everyone will be able to access the data, explore the images, and attempt to identify new objects or unexpected phenomena. This democratization of discovery turns research into a collective adventure, a shared journey through spaces and times never before explored so deeply by any human being. Amazement, however, does not stop at the sheer quantity of information. Every day, millions of signals cross the observatory's servers. Some are simple variations in light caused by planets transiting in front of their stars. Others are more enigmatic signals that require in-depth investigation. Imagine an object that suddenly appears where there was once nothing, a supernova, a gamma-ray burst, or perhaps a new type of phenomenon still unknown. LSST will offer scientists the opportunity to respond almost in real time, organizing global observation campaigns to delve into every new anomaly. Even the way we think about planets, asteroids, and comets is destined to change. The identification of millions of small bodies, tracking their orbits, and the possibility of studying their chemical composition thanks to combined spectroscopy will make the solar system an unparalleled evolutionary laboratory. Every asteroid has a story to tell: its orbit, the collisions it has suffered, the migrations that have led it to move between the gas giants and the Sun. Some of these objects, wanderers at the edges of our system, Maybe fragments that survived planetary formation, or even visitors from other stars. Planetary defense, once the domain of isolated observatories and targeted campaigns, becomes a continuous, distributed process. Every new potentially dangerous object is reported and monitored, providing Earth with an unprecedented scientific shield. Humanity, which for millennia has feared celestial omens, today has the tools to face with rationality and readiness even the threats that come from the sky. Yet the most fascinating question remains. What will we really find as we scan the sky night after night, for 10 consecutive years? What surprises will reality hold for us, now that we are able to see not only what is bright and immobile, but also what is fleeting, dark, and ephemeral? LSST will be our lens on cosmic becoming, a window opened onto the chaos and beauty of the universe in motion. Perhaps, among the millions of expected discoveries, there will be one capable of forever changing our vision of the cosmos and our place within it. So, as night falls over the Andes and the Rubin Observatory lights up its cyclopean eye, humanity prepares to write the next chapter of its cosmic adventure. A journey made of data, of unanswered questions, of new wonders and ancient mysteries just waiting to be unveiled. If you have read this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, write a comment, and subscribe to the channel. It is the best way to support what we do. Your presence truly makes a difference. Until the next exploration.